You have made it to the third and final video of this lesson. This video is going to focus on postulates. Postulates, also known as axioms, are statements that we accept as fact. We accept them as fact because, well, we can't think of or have never observed in several years or millennia any exceptions to the rules. These postulates are the basis of logical reasoning. Our first postulate is the 2 points postulate. It says through any 2 points there is exactly one line. Think about it. A line is a straight path. And if you have 2 points, say A and B, how many straight paths actually go through both of those points? Exactly one. Any other path that goes through those points would have to be curved, and therefore it wouldn't be a line. Can you see why we accept these as statements of fact? They make sense, right? Let's try another one. This is the 2 intersecting lines postulate. So if 2 different lines intersect, then they're going to intersect in exactly one point. So notice here, lines L and M intersect at exactly one point. Once again, if they were to intersect in more than one point, one of them would have to be curved like in our last example. So again, we can accept this as true because we can see that it works. And our third postulate is the 2 intersecting planes postulate. If 2 different planes intersect, then their intersection is exactly one line. And we see examples of this every day. Here is what it would look like mathematically, with line F being the intersection of planes M and P. But in buildings, we see 2 walls come together, and what we call a corner is actually a line. So we see 2 planes intersecting in real life every day. So let's give this a try. Each surface of this figure represents part of a plane, which means they go on forever, so they don't actually stop. So think about that for a second. What is the intersection of plane ABC and plane DHG? You know I love to shade things and simplify figures, so let's do some of that. Points A, B, and C are across the top, so that's the plane ABC. And points D, H, and G are on the right-hand side, so that's the plane DHG. So let's get rid of everything except those 2 planes, and we can see now very easily that they come together in a line, and that's line DC. It's your turn, so pause the video, do these 2 problems really quick. When you're done, come back and check and see if you are right. You're back? Excellent! Here are the answers. To illustrate the first answer there for you, notice that line FB has 2 planes that are coming off of it. So therefore you can see those 2 planes quite easily. Our fourth and final postulate for today is the 3 points postulate. Through any 3 non-collinear points there is exactly one plane. A lot of people will call this the tripod postulate because it's why a tripod works. Have you ever noticed that a tripod never wobbles? It always stays firmly on the ground. And that is because the 3 legs create 3 points, which will always be stabilized on a solid plane. Unlike a table, which often has 4 legs, tables will quite frequently wobble because only 3 legs may be touching the ground at a given time. So let's try this one. What plane contains points E, G, and H? Shade the plane. Once again, let's simplify things. Points E, G, and H are across the bottom down there. So we can now see the plane and we can shade that in. And what plane is that? That's plane HEF, or plane EGH. However you want to name it, any 3 non-collinear points names a plane, right? Let's try another one. What plane contains points A, B, and G? Shade the plane. Well, that one's... Whoa, wait a minute. Notice that points A and B are across the top, and point G is down there on the bottom, clear across the... They're not in the... Wait. They are in the same plane because any three non-collinear points make up a plane. We represent a plane with a parallelogram. So let's see, if we connect points B and G with a line, then draw another line parallel to that through AH, I can see my parallelogram now. Oh, so that would be plane AHG. Do you see how that works? Please keep in mind that just because a plane is not visible in a figure doesn't mean it's not there. Use the 3 points postulate to help you find the plane. Now here are a couple more problems to do on your own. Pause the video, do these really quick, and come back to see if you're right. Well done! Here's the first answer, plane BEH. So this is another one where if you connect points C and H and complete your parallelogram, you can then shade in your plane. For number 4, line AD and line DC go across the top of the figure, so any lines going across the top of the figure will work. So of course line BC, line AB, but also line BD and line AC. Once again, the 2 points postulate lets us know that just because a line isn't visible in a figure doesn't mean it's not there. Feel free to add those lines as well.